Renesas Synergy ISDE how-to video, Advanced Debugging of a Synergy Project. In this video presentation, we will highlight some of the advanced debugging features that you can use when debugging your Synergy projects. Some of the features we will examine are trace display, trace events, breakpoint types, real-time variable display, real-time chart display, visual expressions, and memory monitor modes. After launching E² Studio and opening our project, we will start by briefly touching on how to access each of the advanced features, and then go into each of these independently. Here we see the Trace Display window, allowing you to view the execution of code between point A and point B. The first things we'll point out are the controls for this feature. Here is the on-off button. These other icons control what is displayed, so we have the ability to show assembly-level code, source-level code, MCU bus, which will, for example, show you the prefetch of the instruction. The trace events are basically a trigger condition to do any of the following: start tracing, stop tracing, break emulation, and process a sequence of commands, much like a macro. The type and model of debugger that you have connected to your target will determine what features are available to you. The Breakpoints features have been enhanced from previous versions of E² Studio, and now support both hardware and software breaks. In addition to this, breakpoints can be restricted to certain conditions. For example, only stopping when a specified thread is active. In the Expressions window, you can add global variables and watch them in two different modes. They will be updated when execution stops at a breakpoint, or you can enable the real-time display so that they are continuously updated during runtime. You also have the ability to set the update or refresh rate for this feature. RealTime Chart display can be used to chart either a single variable or multiple variables during runtime. The Memory window is used to display areas of memory in a specific format to match the data. As you can see here, there are many selectable values. The Visual Expressions window can be used to display variables in a graphical representation. There are also graphical controls, enabling you to send values to variables in your application directly affecting operation of the running code. However, you should note that these variables must be defined as global for this feature to work. For example, to send a new value to the code, we can use a button, slider, or knob control object. You can also display objects to monitor variables, for example, a gauge. To use the visual expressions to show a variable during runtime or adjust a variable, we will add a control, a display unit, and also add a graphic indicator object that changes based on a target value's range. Now as we run our application, you can see the results. If we want to chart a variable over time, we can use the RealTime Chart display. Let's set up a single variable to quickly show this. Now when we run, you can see the variable gets charted as it changes. Now for a quick look at the trace display and at least one type of event setup. For this, we will use the Event Break option. Before we start execution, we need to make sure the trace feature is active, which is indicated by the power button control icon. Some other controls that are very useful are the display mode buttons. The grid button is bus mode. The next is assembly mode, and the document icon is for source display. Let's run the application and wait for the event to occur, and then examine the trace contents. The memory usage window shows the amount of memory used in the segments that your application is using. The RTOS views allow you to access certain third-party items like messaging queue, counting semaphores, mutexes, etc. You can step through your code in either high-level or source-level and by assembly-level instructions. Some of the debug windows will adjust if you make different selections. For example, the debug pane will set a focus on that area of the code and be reflected in the registers window, source window, or disassembly window. We can change the mode of specific windows to either link, which switch display based on the selection, or no link, which don't switch based on the selection in the debug pane. You have the ability to not only step through the application in source level, but also in machine language or assembly mode. We will show how some of these features work. Here we'll stop at source level and now switch to assembly stepping. Here you can see that as you change focus on some of the debug windows, you can see that some will directly reflect values based on the focused window. For example, the registers window, source window, and disassembly window. Let's use the memory window to look at a JPEG graphic that is stored in memory. We will first find the memory location by using the pointer to the graphic. And now we will also open a rendering window to display this memory as an image. Alternatively, consider the scenario where you have an array into which you store values based on code operation, and you'd like to see the contents of this array as a waveform display. We can add a memory display to show this. Now let's take a quick look at the breakpoint features. We'll set a breakpoint on a line of code. There are two ways of doing this. One way is to double-click in the margin by the line of code. Or, if you hold the Control key down and double-click, you'll get the Properties box. This allows you to make this a special breakpoint by setting other options like this. For example, regular, hardware, temporary, or hardware temporary. You can also assign an action to the breakpoint, or filter a breakpoint to be only active in a specific thread. You can have a C-level variable in the expressions window that will update as you step through the code, or update when you stop at a breakpoint. For variables that are defined as global, you can also enable Runtime Refresh, which will update the variable continuously while the application is running. Thank you for watching this video. We have provided an overview of some of the advanced debugging features that you can use while working with your projects. We suggest that you keep an eye out for the following tutorial videos as they become available. Using ExpressLogic's GUIX Studio with your Synergy project. Using ExpressLogic's TraceX. Using the RTOS Resources view. Thank you for watching.